Welcome to StudyGap. So in the last video we have learned about logic gates and we have constructed their truth tables. So now today our topic is NAND gate as a universal gate. So you can see on the screen it is written that NAND and NOR gates call universal gate because they can be used to create any other basic gates like AND or NOT gate. That means using only NAND gate you can construct NOT gate. Using only NAND gate you can construct AND gate, and using only NAND gate you can construct OR gate. So let's see how. So first, if we take a single NAND gate and if we connect these two input, then it acts as a NOT gate. That means if you take A as an input here, and you will get Y equals to A complement. So here you can see that this circuit is equivalent to a NOT gate, because in NOT gate if you take A you will get A complement. So we have seen that NAND gate as NOT gate. Next come to this one. So in this figure or in this circuit you can see two input NAND gate is connected to a one input single NAND gate. So now if we take A here and B here, then here you will get A, B complement. Then again here you will get A, B complement, and this is input, so you will get A, B double complement. So that means A, B. So we are taking A and B as inputs, but at the output we are getting AB. So this circuit, or using only two NAND gate, we can construct a AND gate. So here you can see output is AB. So this circuit is equivalent to AND gate, where if we take AB as input we get Y equals to AB. Similarly, for this one, if we take two NAND gate and connect their inputs like this, and then connect this output like this, and the output of this NAND gate like this, you will get a OR gate. Let's see how. So if we take A here, you will get A complement here. Now if we take B here, you will get B complement here. Now this NAND gate will give you Y equals to A complement dot B complement and its whole complement. Now using De Morgan theorem, if we apply the De Morgan theorem here, you will get A double complement plus B double complement. That means A plus B. So we have taken A and B as inputs, but we are getting A plus B as output. So this circuit acts as a OR gate. So we have constructed OR gate using only NAND gates. So now for NAND gate, for OR gate, we know if we take A, B, then we get Y equals to A plus B. So this circuit represents a NOT gate, this one represents AND gate, and this circuit represents OR gate. So we have constructed AND or NOT gate using only NAND gates. That's why a NAND gate is called universal. In the next video we are going to learn about NOR gate as universal gate. If you really like the video, please like, share and subscribe.